Hi, in this video, we'll discuss the convolution operation in mathematics, which is used in areas like signal processing, and we'll be using a similar idea when we talk about convolutional neural networks. So here's a definition of convolution. If A and B are two arrays, then A convolved with B is also an array, and this array at index t is computed like this. So the problem here is, what is A convolved with B when A and B are these arrays? Because these are mathematical objects and this definition is a mathematical definition, we'll also assume that the arrays A and B extends infinitely in either direction, and that if we try to index, let's say, B at -5, that goes beyond the range where B is explicitly defined, then the value of B at that index would just be 0. So this is sometimes called padding in machine learning. And in practice, machine learning models or machine learning libraries will ask you to explicitly define any padding that you are using. But we're just dealing with mathematical convolution here. So let's just assume that we can index B at -5, for example. So as an example, I'm going to change the value of B and solve a similar problem. So what is A convolved with B if we have these choices for A and B? So I'll write down A convolved with B here. And we also have to define a convention for what the first index here is. I'm going to say that this is index 0, 1, 2, and so on. It really doesn't matter what index convention you use, again, because these arrays extend infinitely in either direction. So you could use a different convention and come up with the same answer. So A convolved with B. It might be natural to start with index 0, but I'm not actually going to do that. I'm going to start with index 4, let's say, t equals to 4. And let's try to find what the value is of A convolved with B at index 4. So let me just write this out. Tau A tau B t minus tau. And this variable here, tau, this summation variable, actually goes from -infinity to infinity, which sounds like an impossible sum, but the B term here is going to be 0 for all but 3 values of tau. So most of the terms in this summation is actually 0. And there are really only 3 values of tau where this term is going to be non-negative. So let me just write this 4 explicitly. And the 3 terms of tau, 3 values of tau where this term is non-negative is going to be tau equals to 4, 3, and 2. So this sum now only has 3 elements in it. So let's just write that out explicitly. A2 times B2 plus A3 B1 plus A4 B0. So it's kind of like we've taken B, we've taken B0 and put it where A4 is. And same with B1, put it where A3 is. And finally, B2 here, and put it where A2 is. So we've kind of flipped B and then shifted it. So we flipped and shifted B here. And then now that we have these numbers aligned, we can multiply. Right, we can multiply 1 times 1 plus 2 times 1 plus 1 times 1, and that's going to give me the number 4. If we go to a different value of t, let's say t equals to 5, then we use a different color. Then my summation of over tau of a tau be 5 minus tau. Well, that's, again, this sounds like an impossible summation until we see that b at 5 minus tau is going to be non-zero only at tau equals to 5, 4, and 3. And so we've got a summation over 3 terms here, 3b2, a4, b2, a5. Sorry, that should be a b1. So again, we have this flip and shift. Now I'm shifting my b over by 1. And once I do the multiplication and summation, I get the number 3. And we could keep doing that. So for t equals to 6, what I can do is I can take my flipped b and shift it over. I'm going to get, what am I going to get here? I think I'm going to get 1, right? And t equals 7. This is where it starts to get less interesting. I'm going to get 0 here, 0, 0, and so on. So nothing really interesting here. So 0 after that. So let's go backwards now. So t equals to 4. I think we were here. So let's look at t equals to 3. We're going to be shifting this way now. T equals to 3. We're still going to get the number 4. T equals to 2. We're still going to get the number 4. T equals 1. This gets a little bit interesting. So now we've shifted so that we don't have a value of a here anymore. So we need to multiply this 1 by 0. So we get the value 3. And I'm running out of room, so let me just move this a little bit. T equals to 0. I'm going to get, I think I'm going to get some value. I'm going to get the value 1. And then everything to the left of t equals to 0 is going to be 0. So you can use the same flip and shift idea to complete your problem here.